Swayam Prabha. Digital India. Educated India.
Welcome to the course on our building energy systems and auditing. We are in the module number 6. We are discussing the life cycle analysis and the energy audit. In the lecture number 27, we will discuss today the embodied energy calculation. So, we will demonstrate the step by step method of calculation of embodied energy of a building. And in the last lecture, what we understand is that the initial and the recurring the embodied energy by a method where we have taken the transportation component of it, the manufacturing component of it, and also the construction component of it in separately. In another paper which I have mentioned over here, Ramesh, Prakash and Shukla's paper, they have also proposed another very simple way of calculating the embodied energy, a very simple mathematical model where they have described as the embodied energy I, that is the sum of the ith material. In the initial embodied energy they are talking about is nothing but the summation of two factors like small m I multiplied by the capital M I. They are the quantity of the building materials and the energy content of the material, which we understand, and then there is the addition of the energy used for the transportation for the material to the construction site. They have also proposed the R, the EER. EER is the material embodied energy, but that is a recurring one, where they have used the almost the similar formula, and they have two part of the equation. In the first part, the material quantity, that is the M I, and the embodied energy density capital M I is multiplied with another factor multiplication L B by L M I, which they have stated as the L B is the lifespan of the building and L M I is the lifespan of the material I minus 1. So, it is very similar that what we have discussed in the last class or the last lecture. So, in a little bit of simplified manner, the Ramesh, Prakash and Shukla, they have suggested that. Now, in the embodied energy, what we understand is that we actually deal with lot of material in the building. In different part of the building, structural part, we use concrete, we use steel, we use somewhere in the building maybe brick, plastering, timber, plastics, lot of things, maybe the metals. So, based on those a huge set of material, the NBC 2016 has proposed some classification. It is under the clause number 9.1.4 A. There they have given the 3 or 4 segmented version of the embodied energy. The first segment is for the aluminum, stainless steel, plastic, copper and zinc. If you see, they are very heavy in the sense of the embodied footprint. They have almost more than 50 gigajoule per ton. So, this is the range 50 gigajoule per ton. So, those are very high. So, we will try to reduce the use of it in the construction. Within the 50 to 5 or 5 to 50, we may say gigajoule per ton, Mostly we say, or we have listed down the embodied energy of the material in megajoule per ton, but sometimes it may go so high for those aluminum, steel or so. If you see in the right side graph, if you compare with the concrete or wood, these are too high. These aluminum, copper, plastics are too high, even glass is also too high. So, sometimes they may be talked in the terms of the gigajoule. So, in case of the material of like cement, then again steel, or that is not the stainless steel, it is the reinforced mild steel or so. The glass, bitumen, some of the solvent, cardboard and the papers, these are having little bit less, but also categorized as a very high energy material 5 to 15, but out of this slot the steel and cement are high. I mean high in the sense we require that in a high quantity in our construction. So, you may say that if the cement and steel is so high, so why the concrete is so low in this graph? Because concrete is made of steel, then the cement and also the stone and the aggregates, the stone and the stone chips and the sand. So, it is something like 1:, maybe 2:4. So, the 1 proportion is cement, 2 is your sand and the 4 is your the coarse aggregate. So, definitely a lion's share of the material will be sand and coarse aggregate, whose the energy, the embodied energy is very less with compared to the steel and the cement. Steel also will be required very less, maybe less than 1% or so in case of beam. In case of column, it is less than 4%. So, that is why you even though the steel, I am talking about the reinforced steel and the cement is having very high, significantly high amount of the embodied energy, which is ranging between 5 to 50 gigajoule per ton. But you see the low energy, less than 1 is your sand, aggregate, fly ash and all those stabilized mud blocks, straw bale, bamboo, stones and all. So, that is why if you mix it, so in situ concrete comes under the medium energy within 1 to 5 range. Okay. So, bricks and all those timber, the particle board, medium density fiber board, MDF boards, insulations, in situ concretes are in the medium range 1 to 5 gigaton per gigajoule per ton. So, we can actually take those data from a wonderful the publications made by the Earth Institute, Auroville, and they have listed down the various material and that is predominantly used in the Indian construction industry, and also they have the end of this particular booklet. They have also mentioned that how they have calculated, what is the calculation method or so. I sincerely request you all to please go through that. I will provide this particular material in our forum. It is available freely in the internet also, I mean you can download also, but I will provide you, and I will request you to please go through this particular material, try to understand the what is the energy footprint and the carbon footprint. It is also given the carbon footprint. See, it is the how much kg of carbon dioxide per meter cube of that material which is listed in the column number 1 is also mentioned, and also it is mentioned about the energy quantities in the megajoule per meter cube. It is megajoule per meter cube, it is also megajoule per meter cube unit, and based on some different criterias, they have selected that one in a different criteria, in the sense if you see the unit, it is little different, because this is first one is the megajoule per meter square, which is based on some the area, and this is megajoule per meter cube, which is based on some volume. So, we can use this data. So, as I told in this particular lecture, we have to see the how to calculate what is the step by step procedure. So, I have taken a very simple floor plans of a dwelling, which is yes, this type of one of the dwelling are one of our faculty accommodation in our IIT Kharagpur campus. So, it is a very simple dwelling. We have 2 bedrooms, 1 dinings and the living area with toilets. So, those dimensions and everything are given in the figure. So, what I will do? I will going to calculate the footprint of the energy footprint of this building, except the central part. Only I will do these two, the housing part. So, I will take from grid A to grid D and grid E to grid H. So, grid D and E in between that it is a staircase, and that I am not going to take for my calculation, because it will take little bit longer. So, I want to give you some kind of a glimpse that how this calculation is going to be happen. So, I need some of the data. So, I need material data, I need the sectional view. So, it has 3 floors, ground plus 2, and there are 6 total apartment, each floor 2 apartment, there are 3 floors. It has having a 1.2 meter by 1.2 meter the pad foundation with 300 mm thick, it is having a 300 by 300 mm column throughout with 1.5% steel. I have mentioned here, if you see in the section, the footing is having 1% steel. We have a PCC slab also of 120 mm thick PCC slab, base slab. It has a 300 by 350 the plinth beam, it has a 250 mm brickwork, it has floor beams of 300 by 500. So, those are there in that particular calculations, and there is a 150 mm thick RCC slab is also provided over there. So, I have calculated with my own way. There may be some small error maybe, because I have gone through this particular thing, and then I have estimated the total the energy required. So, the error may involve in detailed calculation with the way we do the estimation and costing, that the central line method or so. So, I have not gone to that much of detail, that you can do always, but I want to give you a glimpse that how through the estimation it can be done. So, there may be some slight variation of the exact estimate with my estimate. So, there are 3 number of floors, there are total number of apartment per floor is 2 that we have seen. We have a plain concrete cement, I will estimate that, I will estimate the concrete, I will estimate for the reinforcement also, because all the percentage are given, I also estimate the contribution. These megajoule per cubic meter values I have taken from this Auroville data, and these are the applications. So, this is only for the subfloor in the ground, this RCC and reinforcement is applied in the RCC work, footing, column, plinth and floor beams and slab, and wall is also is there, I mean contribute brick is used for the wall. So, I am not going to calculate for the floor finish or maybe the window, doors and other painting and all, just these rough calculations I have will going to perform. So, one by one I have performed that one. So, first I have found out what is the volume of the footing, 1.2 by 1.2 by 0.3, and then 1% of the steel. So, every time I did that, I first found out the overall volume, and then the percentage of steels gives me the how much is the steel, and then I deduct that from the whole volume, and I got the volume of the concrete. So, similarly, I do it for the RCC column. So, total length, and then I deducted the beam size and all, and then the total length of the column, and then I have calculated the volume of the each those the column and the steel and the concrete. And similarly, I do it for the estimation of the RCC plinth beam and the RCC roof beam. I am assuming that wherever there is a plinth beam, there is the floor beams also connecting to pillar or the column to column. So, I have taken the way we do our estimation grid line. So, grid A 1. So, how much is the length? 3.5 plus 2.5 plus 300 is the half of the length of the this brickwork or so. So, like that the grid 2 has 3 segment of the wall, that is why it is 3, the grid 3 is also having 3. So, again the other directions A, B, C and D, those 4 grids are there. So, I have calculated all the grid lengths and added up with that. So, total length becomes 76.2 meter, 76.2 meter for both, and the differential the area of cross section of the floor beams and the other the plain beams are taken. So, as it is of the depth of the beam is 500, keeping that 150 mm thick of the slab. So, I have deducted that one, and finally, with the percentage of steel and all I have calculated. So, this is not my intention is not to teach you the estimation, there may be little bit the calculation error, I must say it is maybe error you may say, because of I have not taken the central line method or that method. So, similarly, you can I have found out the RC slab and also the PCC in the ground floor. I have estimated from the AutoCAD file itself. So, from the AutoCAD file I will use the area formula or area the command, and then I have got those values. And for the PCC I have taken the internal the floors, because I know there will be a beam, and for the RCC slabs I have taken whole perimeter boundary. So, that is why it is little bit more. So, like that, and finally, I have calculated the wall. The similar way the grids, this is grid 1 and 1 2 means the grid in between 1 2, that means this is called the 1 2, because this is in between this D2 this wall, this toilet wall or whatever, no, it is a kitchen wall, this is the grid D2. Similarly, there is a 2 3 also, that is this one, this is 2 3. Similarly, there is a is AB, this is AB. Like that, the way we do in our the estimation did, but this is for the 250 wall thickness brickwork, and I have deducted the door and window from that, because we have to deduct that one, that is going to be a good volume. So, the net volume of the 250 wall is something like 19.145 cubic meter. So, that also has been done. Then in next I have calculated the internal partition wall. So, internal partition wall, suppose if I go back. So, if you see this 1 2, this grid 1 2 does not have any 250 wall. So, that is why this length is blank, this length is blank. Even the 2 3 and 3, 2 3 is this, 2 3 is this, and 3 is this. So, it has all internal wall. So, that is why it does not have any 250. So, this is blank. AB and B, AB is this, yes, this is AB and B, B is this one is B, these are also blank, because it does not have any 250. So, like that where there are in which grid what is the length of the brickwork, that I have taken. And another thing I must tell you, suppose if you take the grid number 1. So, I will just erase it, then grid number 1, it is why it is 3200 and 2200. So, the brickwork will be from here to here, right, here to here. So, this is 3500, 3500 is the entire length from the center line of the. So, this is of estimation actually. So, let us still just try to understand the thing. So, this is my column, this is my column, this is 3500 column to column, center line of the column to column. So, this is my brick. So, that means this will be 3500 minus 150 here, and another side it is 150, then minus 3500 minus 300. So, that means it is 3200, that is why it is 3200 for the first one. The second one is what? This one is 2500, the grid to grid, and then again I have to deduct 300. So, it is 2200. Okay. So, that is why. So, like that there is little changes in length. So, I have just calculated the split length between the column to column. Okay. So, that maybe we need to understand. And then the total volume I have multiplied with the height and with the thickness. You may say why the height is 2.5 meter or so, because if you go back to the section. So, this is your 3 meter till here, and this is your 350 from soffit of the slab, but this is your 500. So, this the height of this is 2500 of the wall. So, for all the three. So, that is why the height is this 2500, 2500 is the height, this is the thickness. So, I have transfer everything to meter, and then this is the volume, and then there are one number of W in the first grid, this is one number of W and nothing is there. So, there is the deduction of this much. So, finally, is this much. So, like that I did it for the all. Similarly, the 250 wall is also calculated. See, in the grid 1 there is no 250 wall, because this is the perimeter wall. So, okay. So, similarly, grid A will also not have, the grid number 4 also will not have, because this is all perimeter. This is grid number 4, 1, then D, then A, this will not going to have, even C will not going to have, because there is no partition as such. So, like that those are zeros, and the thicknesses are less now, 225, and the heights are. So, this is something like the estimation. This is not in our domain, not it is our domain, but not in the domain of this energy building energy part, but we need to do this, and we need the specification and also the estimation of the material to convert that one into the energy footprint, embodied energy footprint at least. So, it was 6.5 cubic meter of the 125 mm, the smaller one, and the 19.145 is the thicker one. So, 250 mm brick wall. So, now both are added, just these are the same table, both are added, and I found that I need to have per apartment 25.65 cubic meter of the brickwork. So, I need to have that much. So, now I put all the numbers. So, I have different the materials. See, this concrete 1:2:3 is where it is from the subfloor per apartment. So, this concrete is the for footing per number. So, there are how many footings are there, I have to count. So, there are 30 such footings, there are 30 such columns. So, this is per footing, this is per column concrete, per footing steel, per footing, per column steel, per plinth beam, that is also per apartment. So, like that this is the floor beams and all everything per, this is per estimated as per what we have calculated. This is the final one, the brickwork 25.65. Now, this one is, see, this footing is, there are 30. So, I have multiplied those all number by 30, column is also 30, the plinth beam are per apartment. So, that means I have to multiply with 2, because the plinth beam will be only in the ground. So, there are 2 of such set. The floor beams will be 6, because there are 3 and there are 3, or maybe you may say there are 2 in each floor, there are 3 floors. Similarly, floor slab are also 6, there are floor slabs are also 6, because there are per apartment I have calculated. So, there are 6 such apartment. So, 6, this is 2 for the floor beams, and this is the 2 for the subfloor, because subfloor are in the ground floor only. So, 2, and there are 6 for the brickwork, because there are also like that 6 sets. So, I have multiplied and put up the each value in the corresponding. So, I have 4 materials actually, basically I have a concrete, I have a RCC of different types of concrete, 2 types of concrete, steel and brickwork. So, I have all the 4 material estimate for the for the building, plus please remember the central part of the D to E, that grid is not taken into account, the staircase and the central lobby part, the common lobby part. Now, the things are very easy. I have put in those values 21.45 concrete, which is PCC, then 188.5 something, it is your concrete of steel, the steel is 1.3, 153 is the brick, and then I just multiplied with the corresponding embodied energy, which I got it from the this Auroville Earth Institute data bank and added. So, it is almost like 16,64,670.9 megajoule is the total embodied energy of this particular building. Of course, it is much more, because the central part is not there, and also lot of other materials I have not considered, like brick, the floorings, and also you can definitely do, we can definitely do it, you can definitely add up, and then this probably this value may magnify or so, but this is the whole soul about the, you may say this is the total civil work required this much amount of megajoule. What I did in the next, I convert the megajoule to a kilowatt hour by dividing that by 3.6, because 1 kilowatt hour is 3.6 megajoule. Total built up area I have calculated, that was, of course, I have not calculated the central one, because that is I have not calculated. I have calculated the total built up area of the all the 6 apartments, which is 586 square meter. So, I try to estimate the what is the building footprint, the energy footprint of the building. So, in megajoule, and that was transferred to the gigajoule per square meter, which comes around 2.84 gigajoule per square meter. Whereas, if you say in the kilowatt hour terms, we can say it is having 789 kilowatt hour per square meter by both the values, this value and this value is divided by this value. And the final slide is that this particular code is also given the carbon emission. So, I have taken the first one in the data, that CO2 emission produced as an average of 0.098 kg of CO2 per megajoule of embodied energy. So, if I know this, so I have now converted those megajoule multiplying by this 0.098. So, it is going to be almost like 163.1 tons of carbon dioxide equivalent emission, and then again I divide that by the footprint, the total the built up area. So, that gives me the carbon footprint of the building as almost 278 kg per square meter. So, it has been given in this particular lecture some of the initial and the recurring energy, some other computational method by T. Ramesh and et al. And this it has also provided how to compute the carbon footprint of a building and also the energy footprint of a building. Of course, it is the embodied energy footprint and also taken a lot of other considerations. Thank you very much.